Okay. From today on, we enter the learning for Unit 2. In today's learning goals, after today's class, today's lesson, you will be able to recognize random variables, differentiate discrete and continuous random variables, generate a probability distribution for a discrete random variable by calculating the probabilities for all values, and then represent a probability distribution for a discrete random variable using a table or a bar chart. Okay, first of all, there are some concepts you need to understand. The first one is called random variable. What is a random variable? A random variable is a variable whose value is determined by the outcome of random experiment. This is a definition. Let's see a concrete example. Okay, suppose that. Okay, I'll make a note here. Random variable. Okay, sometimes we denote it as RV. An example. Okay, suppose that our experiment consists of tossing 3 fair coins. If we let y denote the number of heads that appear, then y is a random variable, taking on one of the values 0, 1, 2, and 3 with respective probabilities. Here, y is a random variable. So basically, a random variable first is a variable, right? It has some different values, and the exact values is associated to some random experiment. Can you understand? And usually, a random variable has some meaning, right? Okay, so in this example, y is a random variable. Y means the number of heads that appear in this experiment. So the values of y could be 0, 1, 2, and 3 with some probabilities, right? For example, the probability of y being a 0, that means there is no number of, the number of heads is 0. This probability is 1/8, right? Because there are 8 possibilities in this experiment. And the event TTT has only one sample point. So the probability of y being a 0 is 1/8, right? And the probability of y being 1, that means you toss 3 fair coins. Head appears only once. This probability is 3/8, right? We can easily calculate this probability using our definition. Okay, next one, y being 2. The probability of y being 2, that means tossing 3 fair coins, the head appears twice. This probability is 3/8, right? Okay, next one, the probability of y being 3, that means all 3 times we have head. This event has one sample point. So the probability of this event is 1/8, right? Understand? This is a concrete example of what the random variable is. Okay, so basically, RV is a variable has some meaning. And could be different values, could have different values with respective probabilities. So these are the features for a random variable. Understand? Okay, let's see another example. The following table gives the frequency and relative frequency distribution of the number of vehicles owned by all 2,000 families living in a small town. Suppose one family is randomly selected from this population. The process of randomly selecting a family is called a random or chance experiment. Let X denote the number of vehicles owned by the selected family. Okay. Here we have a letter X denoting the number of vehicles owned by the selected family. So X is a variable first, right? Because X could have different values with respective probabilities. So X is also a random variable, right? Because before the experiment, you do not know the value of X. X could be any value, right? Any value within 1, 0, 2, 3, 4. Only after the experiment, you can say X is which number, right? Then X can assume any of the 5 possible values, 0, 1, 2, 3, 4, listed in the first column of the above table. The value assumed by X depends on which family is selected. Thus, this value depends on the outcome of an experiment. Okay, pay attention to this sentence. This value depends on the outcome of an experiment. Consequently, X is called a random variable or chance variable. In general, a random variable is denoted by X or Y. Actually, you can use any letter to denote a random variable. That doesn't matter, right? Usually in most books, we use uppercase X or uppercase Y or uppercase Z to denote a random variable. Okay, any questions? Do you understand what a random variable is? All right. If you have no questions, we can move on. There are 2 types of random variables. The first type is discrete random variable. Okay, discrete random variable means 离散随机变量 in Chinese. Or 离散型随机变量. What is a discrete random variable? Let's see the definition first, and I'll give you some examples following the concept, okay? By definition, a random variable that assumes countable values is called a discrete random variable. A discrete random variable assumes values that can be counted. In other words, the consecutive values of a discrete random variable are separated by a certain gap. Okay, for example, the number of cars sold at a dealership during a given month is a discrete RV, right? Because it can only have values of natural numbers, that is 0, 1, 2, 3, or etc. Okay, number 2, the number of houses in a certain block. This as well is a discrete RV because it also can have only natural numbers, right? 3, the number of fish caught on a fishing trip. 4, the number of complaints received at the office of an airline on a given day, which is also a discrete RV because it can only have values of natural numbers, right? Okay, by comparison, the second type of random variable is called continuous random variable. By definition, a random variable that can assume any value contained in one or more intervals is called a continuous random variable. Right? A random variable whose values are not countable is called a continuous random variable. A continuous random variable can assume any value over an interval or intervals. Okay, this means that in your number axis, there at least exists one interval that this random variable can be any value within this interval. There exists at least one such interval, right? Okay, some examples of continuous random variable. 1, the length of a room. Why is it a continuous random variable? Because the space is continuous, right? For example, the length of a room could be 5 meters to 6 meters. There exists an interval that is 5 to 6. The length of a room could be any values within this interval, right? Because space is continuous, so the length of a room is a continuous RV. Continuous RV means 连续型随机变量 in Chinese. Example 2, the time taken to commute from home to work. Okay, this is also a continuous RV, right? Because time is also continuous. For example, the time taken to commute from your home to work is between 20 minutes to 30 minutes. And there exists an interval, which is 20 to 30. Time taken could be any value within this interval, right? Okay, similarly, the amount of milk in a gallon is also continuous random variable. The weight of a letter, for example, 1 gram to 2 gram, is also a continuous random variable, right? 5, the price of a house, for example, 1 million to 2 million, could be any value within this interval, is also a continuous random variable, right? Any questions? Can you tell what is a discrete and what is a continuous random variable now? Okay, let's do a quick quiz. I'll leave you 5 minutes to finish this, all right? And then let's discuss these solutions together. Okay, quick quiz. Classify each of the following random variables as discrete or continuous. A, the number of phone calls made by a salesperson. B, the length of time salesperson spent on the telephone. C, a company's annual sales. D, number of veggies sold by the company. E, the distance from Earth to Sun. Okay, classify each of the following random variables as discrete or continuous. Okay, you can start now. All right, have you finished? Okay, let's see result. The number of phone calls made by a salesperson is discrete, right? Because the number of phone calls must be an integer, so it has to be discrete. Okay. The length of time the salesperson spent on the telephone, this is continuous. Because the time spent can be measured to fractions of a second. For example, it could be 10 minutes to 20 minutes. There exists the interval. The length of time can be any values within this interval, right? See, a company's annual sales, this is discrete. Because sales are a whole number of dollars and cents. It cannot be beyond cents, right? Sales can only be whole number of dollars and cents. D, the number of veggies sold by the company. This is also discrete. Because presumably the company sells only whole veggies. It can only be an integer number. There does not exist an interval. The value can lie within that interval. There does not exist such an interval, right? E, the distance from Earth to Sun. Okay, this is continuous. Because space is usually continuous. For example, Earth's distance from the Sun varies continuously, since Earth moves in a elliptical orbit around the Sun, right? Okay. Any questions? Now you should be able to tell what is a random variable and what type of a random variable. Is it a continuous or is it discrete? You should tell the difference now. Okay, next one. Probability distribution of discrete random variable. So we have already know what a discrete random variable is, right? Next question is, what is the proper way of describe a discrete random variable? Okay, let's see first let's see the definition. Let x be a discrete random variable. The probability distribution of x. Probability distribution of x describes how the probabilities are distributed over the possible values of x. The probability distribution of discrete random variable lists all the possible values that the random variable can assume and their corresponding probabilities. Okay, pay attention to this sentence. Lists all the possible values that the random variable can assume and their corresponding probabilities. So basically, the probability distribution of discrete random variable is actually a table, right? On the first row, okay, for example, we use the letter x to denote a random variable. On the first row, we list all the possible values, such as x1, x. Oh, okay, we use another letter here. Do not use x1. Okay, suppose the discrete random variable is x, and x can assume different values such as k1, k2, k3, etc. and km. And on the second row, we list the probability of x being any number ki. Okay, so here we list the probability of x being k1. Here we list the probability of x being k2. And in the similar way, we list all the probabilities of x being any value. So this table is actually called probability distribution of a discrete random variable. From this table, we have all the informations regarding this discrete random variable, such as we know what values this discrete random variable can assume and the corresponding probabilities associated with that value, right? Okay, this is very important. Remember this, okay? Remember the concept of probability distributions of a discrete random variable. Okay? Okay, let's see a concrete example. Okay, on the left-hand side, there is a frequency and relative frequency distribution of a number of vehicles owned by a family. This is abstracted from our previous example. And on the right-hand side, there is a question. Let X be the number of vehicles owned by a randomly selected family. Write the probability distributions of X. Okay, this problem asks you to write the probability distribution of X. Okay, according to the definition, the probability distribution of X should list all the values X can assume and all the corresponding values, the corresponding probabilities, right? So basically, it's a table that lists all the values X can assume. Okay, let's see. First, let's see what values X can assume. That is actually depends on the meaning of X, right? The meaning of X is that X is the number of vehicles owned by a randomly selected family. That means if I randomly select a family, X denotes the number of vehicles owned by the family, right? So the value of X could be 0. That means the family owns 0 vehicles, or 1, or 2, or 3, or 4, right? The family could own 0, 1, 2, 3, or 4 vehicles. And then on the second row, we list the probability of X being any values within all the 5 possible values, right? So what is the probability of X being 0? That's actually a ratio, right? You have 2,000 families in total. So how many families owns 0 vehicles? We check the frequency here, right? So the result is actually 30 by 2,000, which is 0.015, which is actually called the relative frequency, right? So all we have to do is to copy the relative frequency onto this table. Okay. So the probability of X being 0 is 0.015. And the probability of X being 1 is 0.235. And the probability of X being 2 is 0.425. And the probability of X being 3 is 0.245. And the probability of X being 4 is 0.080. And all these numbers should add up to 1, right? Because there are only 5 possibilities. Okay, understand? This table is called, this table is the probability distribution of X. Understand? Do you have any questions? No? All right, let's see the next. Okay. Besides this table, there's another form that we can use to represent the probability distribution of X, which is a bar chart here. We can also use a bar chart to illustrate the probability distribution, in which the x-axis is all possible values that the random variable can assume, and the y-axis is actually the corresponding probabilities. Understand? So this bar chart is actually the same with this table. These two are the same, right? The only difference is how they represent these values. The table simply lists all the values on the table, and the bar chart is listing all the values using a diagram here. But basically, these are the same, right? To draw the bar chart, you have to have the table first. Understand? Okay. And another important aspect is the two characteristics of a probability distribution. Remember these two. The probability distribution of a discrete random variable possesses the following two characteristics. Number one, for each value of X, the probability of X lies within an interval 0 to 1. Okay, that means for each possible value of X, the possibility of X should be equal to or above 0 and equal to or less than 1. Okay, this is the first characteristic. Okay, the second characteristic is for all values of X, the sum of their probabilities is always 1. Because probability cannot be above 1, right? Okay. Let's see an example. Verifying the conditions of a probability distribution. Each of the following tables lists certain values of X and their probabilities. Determine whether or not each table represents a valid probability distribution. Okay, I'll give you 5 minutes to finish this quiz. Okay, have you finished? Okay, let's see the first one. To qualify for a probability distribution, it has to fulfill these two characteristics, right? Okay. Because each probability list in the table is in the range 0 to 1, it satisfies the first condition for probability distribution. However, the sum of the probabilities is not to equal because the sum is only 0.85, right? So this table is not a probability distribution. It does not fulfill the second condition. Okay, the second one, each probability list in this table is in the range 1 to 0. Also, the sum of all the probabilities equals to 1. So this could be a probability distribution. Okay, C. Any probability cannot lie out of the 0 to 1 range, right? So this one is not a probability itself. So this one is not a probability distribution. Okay, any questions? No? All right, let's see a quick quiz. Okay. The following table lists the probability distribution of the number breakdown per week for a machine based on past data. Okay, breakdowns per week could be 0, 1, 2, 3. The probability of being 0 is 0.15. The probability of this value being 1 is 0.2. The probability of this value being 2 is 0.35. The probability of this value being 3 is 0.3. Okay, question A. Present this probability distribution graphically. That means to use a bar chart to present this probability distribution. Okay, question B. Find the probability that the number of breakdowns for this machine during a given week is exactly 2, 0 to 2, more than 1, or at most 1. So basically, it asks you to calculate the following 4 events, the probability of the following 4 events, right? Okay, I'll give you 5 minutes to complete this question. Okay, finished. Okay, let's see the solutions. Okay, usually we need to use a letter to represent the random variable, right? Okay, here you can use x. Let x denote the number of breakdowns. For this machine. During a week. And then we can draw a bar chart here. Okay, x-axis is the random variable x. And the x assume values of 0, 1, 2, 3, right? Okay, the probability of being 0 is 0.15. Okay, here is 0. And the probability of being 1 is 0.20. A little taller than the previous one, right? Okay, its next value is 2. The probability of being a 2 is 0.35. Okay, and next value is 3. The probability of being a 3 is 0.3. Okay, so this is a bar chart that we can use to represent the probability distribution. So it's basically the same with this table, right? Okay, question B. Find the probability of the following 4 events. Okay, number 1, the probability of x being 2. You can write it in this way. The probability of x being 2, right? This we can find this value directly from the table, which is actually 0.35, right? Okay, second one, the probability of x lies within 0 and 2. Okay, in this interval, there are 3 values, right? The probability of x is equal to or above 0, and equal to or less than 2 is actually the probability of x being 0 plus the probability of x being 1 plus the probability of x being 2, right? Because x can only be these 3 values within this interval. So x being 0 is 0.15. X being 1 is 0.20. The probability of x being 2 is 0.35. And the sum is 0.70, right? Okay. Question 3. The probability of x being more than 1. Okay. X being more than 1 means x could be 2. And x can also be 3, right? So we sum these two probabilities together and they can get the probability of x being above 1, which is 0.35 plus 0.30, which is 0.65. Okay, so last one, at most 1. That means the probability of x being equal to or less than 1, right? Within this interval, x can only be 1 or 0. So the probability is 0.20 plus 0.15, which is 0.35, right? Any questions? No? No question? Okay, then we'll move on. Okay, let's see the last example, okay? According to a survey, 60% of all students at a large university suffer from math anxiety. 2 students are randomly selected from this university. Let X denote the number of students in this sample who suffer from math anxiety. Develop the probability distribution for X. Okay, it tells you X denote a random variable, and it asks you to develop the probability distribution of X. Remember that usually we use a table to represent the probability distribution of X, right? Okay, I'll give you 5 minutes to finish this quiz. Then we'll discuss it together. All right, finished. Okay, let's discuss the solution here. Okay, if we use two letters to denote whether the students suffer or not suffer, for example, we use F denote suffer, and use N denote not suffer. Okay, we choose two students from a very large university. Every time we choose, there is a 60% possibility that the students suffer, right? Okay, pay attention, because it's a large university, so 60%, this number does not change each time you select a student from this university. So you can think it as independent events, right? The result of choosing the first student does not affect the result of choosing the second student. So how many possibilities can you choose? Two students could be both of them suffer, or the first suffers, the second not suffer, or the first not suffer, second suffer, or both of them not suffer. There is only 4 possibilities, right? And here it tells you X denotes the number of students in this sample who suffer. That means X could be 0, right? Or 1 or 2. That means we can have 0 students suffer, or only 1 student suffer, or both of them suffer. X can only be assigned to these 3 values, right? And the next step is to calculate the probability corresponding to each value, right? Okay, so the first, we can calculate the probability of X being 0. That means none of them suffer from mass anxiety, right? Okay. That means the probability of none of them being suffered. Okay. With the first student not suffering mass anxiety, the probability is 0.4, right? Okay, because they are independent. So PNN is actually PN multiplied by PN, right? Because they are independent. So it is 0.4 by 0.4, which is 0.16. This is the probability of X being 0, right? So similarly, we can calculate X being 1. This means one of them suffers from mass anxiety, right? Could be the first one or could be the second one. So this probability is Sn or Ns, right? And according to the formula, the union of two events is the probability of the first event and the probability of the second event minus their intersection. Okay, Sn and Ns cannot exist at the same time, so this probability is 0, right? Okay, so the probability of Sn, that means the first student suffered, that probability is 0.6. Second student not suffer, that probability is 0.4. Okay, the second one, the first student not suffer, that probability is 0.4. Okay, the second student suffer, that probability is 0.6 and minus 0, which is 0.48. So the probability of X being 1 is 0.48. Okay, so similarly, we can calculate X being 2. The probability of X being 2 is actually the probability of SS, right? Because both of them suffer from mass anxiety. Okay, so this is actually because the two events are independent, so this is PS multiplied by PS, which is 0.6 by 0.6, which is 0.36. So now we can have the probability distribution. It's actually a table. First row is to list all the values x can assume, which is 0, 1, 2, respectively. And the second row, we list the corresponding probability. So the probability of x being 0 is 0.16. The probability of x being 1 is 0.48. And the probability of x being 2 is 0.36. And we can validate if this probability distribution fulfills the two conditions, right? Apparently, the first conditions can be fulfilled because because all of the probabilities lies within 1 and 0, the interval between 0 and 1, right? And the second condition, the sum of all the probabilities should be 1, right? Let's validate this. Okay, 0.16 and 0.48 is 0.84, right? And if we add these two numbers, this is a 1.0. So the validation pass. Right? This is only for validation purposes. You don't have to write this in solution, right? Okay, that means we calculate the probabilities right. Okay, all right. This is main points for today's lessons. All right, I'll leave the rest of time for you to do your homework.